Uh, Good evening, everybody. Science People Delhi has been conducting online talks on various science subjects since 2020. These talks were done by eminent scientists, science teachers, science communicators, and a couple of times even amateur science followers. Till date, we have completed 85 talks. Apart from these talks, we had given opportunity to our young talents to share their knowledge in this same platform. All these talks, except one, are available in our YouTube channel. Our aim is to bring the knowledge that humankind have acquired over a period of time to common people. All our past speakers contributed to our journey in every possible way they could. We would like to thank all of them for their continuing support to the cause. Today is the 86th talk in the series and live in statistics. This is a tribute to the legendary Indian scientist Prof. R Rao, who was a genius in mathematics and statistics. He is a recipient of many awards, including International Prize in Statistics, which is considered an equivalent of Nobel Prize in Statistics. To share more detailed information on his life and work, today we have with us Professor V Rao, Professor Debasis Kundu, and Dr. Satheesh S. We welcome these three eminent statisticians on the board. We also welcome each one of you to an enlightening talk and interactive session after the talk. Dr. Satheesh did his master's in statistics from University of Kerala and PhD from Cochin University. He was working in Department of Telecommunication and BSNL before taking voluntary retirement to follow his passion in teaching. He has been teaching in various places and now he is teaching in NG University, Kottayam. I once again welcome all of you and I request Dr. Satheesh to introduce Professor V Rao and Professor Kundu in detail and moderate the session also. Thank you. Dr. Satheesh, please take over.
Thank you, Ramesh, for the nice introduction. And good evening, one and all assembled here. I am privileged to extend a warm and cordial welcome to Professor V Rao and Professor Debasis Kundu, and also to introduce them. We, science people, are very grateful to both the professors for supporting our endeavor. The occasion for today's talk is that Professor Sir Rao, who was a well-known mathematician and statistician over the last 8 decades, is no more. He passed away peacefully on 22nd of August 2023, just 3 weeks short of his 103rd birthday. He was born on 10th of September 1920. So here I am introducing the eminent professors, Professor V Rao and Professor Debasis Kundu, both of whom were associated with Professor Sir Rao, so that we can hear from them what was Professor Sir Rao, his activities from different perspectives. Professor V Rao is an adjunct professor at Chennai Mathematical Institute, Madras. He took his PhD from ISI, Kolkata in 1970 with Professor J.K. Ghosh and Professor A. Maitra. His areas of interest are set theory, analysis, probability, and applications. He is a wonderful teacher, and I am fortunate to have attended one of his courses on Wiener process way back in 1986 in a summer course at ISI Kolkata. He likes reading Telugu poetry and listening to Indian classical music and Veena especially. He is also good at sports, especially badminton, TT, and is also a good swimmer. Now coming to Professor Debasis Kundu, he is with the Department of Mathematics and Statistics at IIT Kanpur. He did his PhD in statistics from Pennsylvania State University with Professor Sir Rao, whom we are commemorating today. His areas of interest are statistical signal processing, nonlinear regression, survival analysis, generalized exponential distribution, and also statistical computing. Let me first invite Professor Debasis Kundu, as he has indicated that there is some time constraint on his part. So let me hand over the mic to Professor Debasis Kundu. Sir, please.
Yeah. Thank you. Thank you, Professor Satheesh, for the kind introduction and for inviting me for this tribute to Professor Rao. It is indeed a great honor, and I am very much privileged to work with Professor Sir Rao. I mean, absolutely, there is no doubt about it. But for that, I would like to thank, another Rao, which is our teacher, Professor V Rao, also, because he has basically prepared us and motivated us to go for PhD, and that was the reason that I could meet Professor Rao, because Professor V Rao was our teacher and at ISI, and he taught us some of the most fundamental courses and really motivated us to go for the higher study. And that time only I could meet Professor Rao. So I met Professor Rao actually in first time when I had gone for my PhD in '84 after finishing my master's. And well, I mean, by that time, Professor Rao has already become Professor Rao, and we are really just looking at him from a distance, because it was, we are all scared of him. It was not very easy. So anyway, the first class was very interesting. I took the first class in his second semester. That was and he was an amazing teacher. I mean, unbelievable. And I mean, the way he used to teach. I mean, it is definitely amazing. I mean, so anyway, so after, I mean, I did couple of courses under him also, and then I finished my comprehensive. And then actually during the interview of the comprehensive, it was, I think, one of the significant day on my life, because Professor Rao, after finishing the interview, he asked me whether I would like to work with him. I mean, it was as if coming from a God's voice. I mean, nothing can be more than that. So anyway, so, and that was the most amazing journey, because he told me to meet him after a few days in his office. So I went to his office, and he gave me 3 theses. 2 of them are from the electrical engineering, and 1 from the mathematics. There was no statistics thesis. I mean, there was 2 electrical engineering and 1 mathematics one. And he said this one, that look, I think these people are trying to solve this problem, and I think they are not doing a good job. And if you can solve this problem, I'll give you PhD. Okay, so that was the way my journey has started about my PhD, and and well, I mean, it was, see, during that time he was also not working in that area. I mean, but he could see the potential of the problem. I mean, that was Professor Rao. I mean, that was amazing. I mean, that was Professor Rao. He could see the potential of the problem. I'll come back to the problem. I'll show you the problem. But anyway, so I started working on it, and I got my PhD after 2.5 years after starting that problem. But what I would like to talk about the kind of diversity. I mean, it is unbelievable. At that time, 6 of us are working that time we were working on the PhD during that time, and out of those 6, 2 of us were working on statistical signal processing. One of them was working on the meta-analysis. Another was working on model selection. Another was working on the L1 norm regression, and another was working on the differential geometry. So you can see that, I mean, how a person can guide a students in the different areas like this. I mean, I don't think that not too many people will be able to do that. Okay, so anyway, so that was Professor Rao. That was Professor Rao, and apart from the 6 students, he had, I think, almost like around 8 to 10 postdocs, and of course they are also working on the different areas. Okay, and that's the way. That's the way it was Professor Rao. And one of the most amazing thing I have seen about Professor Rao is that his appreciation of the work, and it really does not matter what kind of work it is, whether it's a theoretical work, whether it's a computational work, whether it's a purely applied work. As long as it is good, he appreciates it. Okay, so and I think that makes a difference. That, I mean, that is the thing. I mean, that was, I think, the difference than the rest of the people. And frankly speaking, I appreciated more and more when I grew up. Okay, as I am getting matured age-wise, and I can appreciate him much more, and I can see that's one that, oh my God, I mean, how a person can be of that kind of a diversity. Okay, so yeah, I just want to share a small file just to show this one, that the fundamental problem he has worked on, the statistical signal processing, because I don't think too many people are aware of his contribution in the signal processing area, because all of us know about his contribution in inference, in probability, in estimations, in linear models, in design, and all these things. But I don't think too many people are aware about his some fundamental contribution in signal processing. Okay. Yeah, exactly. So it is just a few slides, and I just want to mention about Professor Rao's contribution. He has worked actually not for a very long time. I mean, he has worked mainly around 10 years. He has started actually working on this statistical signal processing after I finished my PhD in 1989. And I think he got enough interest into that one. And another student also did her PhD under Professor Rao after me, and he has started working with some of his postdoc. I think in the 90s, the first paper came out in 93, and he has worked till 2006. During that time, he has basically made around 14 papers, but I think all of them are quite unique, and I'll just briefly mention. I mean, and most of them you can see that they have been published. I think the prestigious journal Signal Processing in IEEE Transactions on Signal Processing, and one of the paper came out at the Proceedings of the National Academy of Sciences USS, which is definitely one of the topmost journal in science. So that shows that the kind of contribution he has made it during those 10 to 12 years, and he has a handbook also on the statistical signal processing with Professor N.K. Bose, which is a signal processor who is also no more at this moment. And I was visiting Professor Rao, I think again in 2008, and that time I was still working on the signal processing. And when I was giving the talk at Penn State, he made a comment. He said that, well, I had stopped working on signal processing, but Kundu is still continuing. And yes, so let me just mention the major contribution. And I think so this is one of the very fundamental problem in the signal processing, statistical signal processing, which looks very innocent model. It's a nonlinear regression model. The model which is a complex value. I'll come to this one. It's a complex valued one. So basically, the problem is very simple. The problem we can put it in a very simple manner. You have the observations. You have the signal, which is of the form of summation ak e to the power I omega kt. K is equal to 1 to p. There are p components. There is some additive error. and at this moment you can take it to the complex value. So the main idea is to extract from the signal, the noisy signal yt, you have to extract the number of components, they call the number of signals also, which is p, the amplitude parameters, the a1, a2, ap, and the frequency parameter omega 1, omega 2, omega p. And under different, of course, different error assumptions, we have this one. So this is a problem which was first he has given it to me, and that time, of course, I have no idea. But then I have found this one that it has a significant applications, and this is actually one of the most fundamental model in the statistical signal processing area. And it has is actually a nice, very, very convenient, the real part, what you call the real value component, which can be written as a sine and the cosine term. And the main point is that any the periodic signal which can be captured using this particular model. Okay, and so he has basically worked on this one quite significantly. Not only this one, many of these related model, and I think that main significant contributions is that the way of thinking, the way the problem can be attacked, and the problem should be we should think about the problem, and of course the finally the solutions. Okay, so I think with this I'll stop it, and if anybody has any questions, I'll be very happy to answer this one. Okay, thank you very much. Yeah. Yes.
So if any questions are there, please post them. He will be happy to answer your queries.
I just want to know one particular thing. This the work you have done in signals. Can you just relate it to our normal activities, whatever it may be, maybe in railways or what, that we couldn't get it. Sir,
can you hear me? I know he's stuck actually.
I think he said.
She said he's again frozen.
Oh,
Okay. We may go with Dr. Rao and then we can come back.
Hello, Professor Kundu. It appears that yeah, on your side there is still some problem with the network. Shall we proceed with the Professor V Rao?
Yeah, it seems to be. Yeah.
Okay. Professor Rao, are you there?
Yeah.
I think we can proceed with your talk, because again that side is kind of frozen now.
Oh, I see. There is a problem with the.
Yes.
Okay.
Okay, sir.
So,
please.
Thanks to the forum, and thanks Professor Satheesh S for the kind invitation. So basically, I am going to talk about Dr. Rao, the person, and Satheesh requested me to say about his some of the contributions. So I will do both. Okay. Okay. Can you see?
Yes, sir.
Can you see the presentation?
Yes.
Okay, good. So this is a tribute to the statistician by the Science People Forum. I am very happy that you decided to do that. And as Satheesh already said, 10th September 2022. And his supreme goal was quest for new knowledge and solving practical problems. Okay. So rather than giving the entire biodata and where he was, what he was, and so on, Satheesh requested me to say about the person and so on. So first thing I would say, he is very informal. When I went to ISI in 65, sometimes he would even walk with what we call Hawaii chappals, And when I was a research student, for example, Nat Kearney, he is a famous ergodic theorist and so on. Nat Kearney, M.G. Nat Kearney came to join. So he went to Dr. Rao's office and showed his letter. And Dr. Rao said, oh, you have come to join. Very good. And then he takes him to the room next and takes a feather duster. He cleans the table, he cleans the chair and tells him, this is your office. And then he calls one research scholar and tells him to take him to hostel and so on. So that was sort of very informal. Dr. Rao himself doing that. And K.R. Parthasarathy, very well-known probabilist, he told me that when he went to ISI as a student, he went one day late. So there is a class going on. Somebody was lecturing. He looked like an ordinary person, wearing purple and so on. And he asked KRP, where is your practical notebook? And KRP said, I have come late. I will buy and bring tomorrow. And the lecturer said, some sternly, he should bring. And KRP did not like it. He wanted to complain to Sir Rao. So he went to Sir Rao's office. And whom does he find? He finds the same lecturer. He did not imagine that this ordinary looking person is Sir Rao. So that was how he was. And he always encouraged youngsters, when you see him in a corridor or somewhere, he would just ask, what are you doing now? What are you reading? That itself is a great encouragement. And ISI campus has a large number of ponds and so on. Well, not large, but some ponds. And usually in the evening, it is the custom to walk around the pond. So he would also walk. He was very accessible. People could talk to him. And anything can be discussed in mathematics and so on. And the interesting thing, these are all things that youngsters should try to emulate. There was a what we call pew or attendant, always sitting on a stool next to his office, so that he can do work for Sir Rao. But this old man is very interesting. There are exactly two things he does sitting there. Either he is taking a nap, okay, or he is seriously reading a Bengali book. And in either case, Sir Rao would not disturb him. If he is sleeping, how can you disturb? Taking a nap. So he would take the paper to the office himself. And if this old man is seriously reading a Bengali book, then how could Sir Rao disturb somebody? So he would take the paper himself. So we found that most of the time he was doing the job himself. And the public also respected ISI workers because of the academic atmosphere. Even if there was a bunk, if I come out and say I am going to ISI, they respectfully allow you. Must understand that collections are time. So if they are allowed to go, that itself is a great respect. And after PCM passing away, PCM is Prashant Chandra Mahalanobis, PC Mahalanobis, the founder of ISI, politics took over, unfortunately. And whenever politics takes over, something has to suffer. So he was made to leave, but his heart was always at ISI. He visited ISI several times. He was very happy, never unhappy or anything that he was made to leave. And about his work ethics, nowadays we look at the calendar, central government or state government publishes holidays and so on. But in those days, Dr. Rao, if it is a holy festival, he would say, you can play colors in the morning. We'll have classes in the afternoon. And during Deepavali, what is Diwali, he would say, we'll have classes daytime. Anyway, you will celebrate in the evening and night, right? So, kind of thing, most of the time, it is study that was stressed. And there is famous R Rao, harmonic analyst, he said, he is no longer there, but he worked all the time. He means Sr. Rao worked all the time. It showed us why he was successful. I was working in the United States in the 90s on a very difficult problem. I was not making any headway when I went to see him. He was in Pennsylvania at that time. And I saw how hard he was working. I came back, and that extra push made me get the solution. So, that is the thing. He used to work all the time. And about the academic administration, he started along with Haldane and Mahalanavi, the B-Stat, M-Stat courses. They have no parallel anywhere. And he started a biostatistics specialization at ISI, which includes genetics, long before it became important. And he started operation research specialization, including optimization techniques. Maybe he was motivated by the 5-year plans. He started a pre-research course. He felt that those coming from universities are not having enough background. So before making them as research students, some background should be given to them. So this is the training. So he was always trying to see how to improve. And he knew the importance of computers very early. Right now, of course, we use computers every minute, but in 1966 and so on, it was not that popular. He tried to develop softwares. And he says, we could have been world leaders in statistical software, okay? He tried hard. ISI Workers Union prevented me from using computers. That is what he said. We lost the opportunity to develop computer-intensive statistical techniques in India well before others did. The clock was set back by 20 years. This was a big disappointment for me. I had even sent a resignation letter, but Professor persuaded me to stay. So he tried to develop software. Okay. Now, apart from this personality, there are several other things. But let me spend a few minutes on explaining his work. Some of you are experts, so excuse me. I will try to tell so that it can be understood by general participants, even though they may not know much statistics. Okay, he worked, contributed to several areas: estimation theory, statistical inference, multivariate analysis, factorial times, orthogonal arrays, biometry, statistical ethics, generalized matrix inverse, characterization problems, functional equations, many. Okay, but I will just mention a few things. The very famous thing is the so-called Kramer-Rao lower bound. This is C.R. Rao. This is Harold Kramer. What is that? That gives you a lower limit for the variance of an estimator of an unknown quantity. Statistics mainly deal with trying to find the unknown from observations. Even the simple thing as room temperature is meaningless because temperature is a point thing. At a point you can measure. So to take room temperature, you have to take the temperature at a few points in the room and take the average. Or when you estimate something unknown, you take a function of your observations. That is called estimator. Once your observations are put here, you will get a number, that is the estimate. Now, there are several estimators you can propose, but whatever you propose, that estimate has a certain minimum variance. That is what he discovered. It is amazing. A person working isolated in Calcutta discovering that. Another thing he discovered goes by the name of Rao-Blackwell theorem. What is that? Best estimators are functions of sufficient statistics. What is that? When you have a model for a phenomenon, you don't have one model, you have several models, and you want to find out which is the correct model by making observations. Now, there are certain statistics. What is a statistic? It is a function of the observations, which are called sufficient statistics. So what this theorem says is best estimators are functions of the sufficient statistics. If you have an estimator, if it is not a function of sufficient statistic, you can improve it by taking additional adaptation and making it as a function of sufficient statistics. Another thing is the Fisher-Rao matrix. Rao here, Ronald Fisher. Fisher is a great statistician. He visited India several times. This metric is a metric between two distributions in a parametric family. I said, so if you have a phenomenon you want to model, there are several models you will put and see which is the best. So between two models, you can define a distance. Okay, this family is called a parametric family. So for those families, he defined a distance. Later, this distance was recognized as something related to Riemannian metric. So people started using differential geometry. Apart from this, there is something called Rao's score statistic for testing of hypothesis. This is C.R. Rao. This is called a holy trinity. There are three kinds of famous tests: likelihood ratio test, Wald test, and Rao's score test. What is testing? I have a coin. I want to find out whether the chance of first is 0.2 or 0.3 and so on. I am not interested exactly. I want to know yes or no. Okay. Let us say, is it smaller than 0.2 or is it bigger than 0.4? Okay. I don't want exactly what is the value. So you want to perform an experiment and Based on observations, you will make a number. If that number satisfies certain condition, we will say this is correct, otherwise that is correct. So this Rao score test, which is again based on variance and covariances, is supposed to be a very good statistic used in econometrics. And he contributed very much orthogonal arrays. So what are they? They are combinatorial arrangements useful for construction of a variety of designs for agricultural, medical, and other experiments. You see, suppose you are trying to find out two breed of rice, okay, two varieties. You want to use some kind of fertilizers. How do you perform experiments? There is a problem. If you grow one variety here, another variety there, then maybe soil here is good, soil there is bad. There are several other effects. So you have to replicate so that both varieties are grown on this soil or also on the other soil. You have to arrange your field in such a way that several combinations are visible in your experiment. So to do that, you need these orthogonal arrays, and he has fundamental contributions to G inverse. What is it? You know, inverse of a matrix, if it is invertible. If it is not invertible, even then you want to talk about it's a generalized inverse. It is just like taking a one-sided inverse map. And this he needed studying long-term effects of radiation. Then he worked in shape analysis. He was working with a doctor, cardiologist. Of course, right now there are all sorts of medical things, but in those days it was very primitive. They will take X-ray pictures in different directions and then try to find out what is the shape, okay? That was in 60s. So he did that. And these are not only things. He has written several books, Advanced Statistical Methods for Biometric Research, Linear Statistical Inference. This is translated into several languages: Computers and the Future of Human Society, Statistics and Truth, Generalized Inverses, Characterization Problems, and so on. And to conclude, I will just give a quotation. Sir Rao himself. We study physics to solve problems in physics, chemistry to solve problems in chemistry, botany to solve problems in botany. There are no statistical problems that we solve using statistics. We use statistics to provide a course of action with minimum risk in all areas of human endeavor, with unavailable evidence. That is the crucial phrase, with unavailable evidence. Okay. So that is what Sir Rao says about statistics. There are several other things. So thank you all. I give a slide of the fundamental things: Kramer Rao lower bound, Rao equal theorem, Fisher Rao metric, orthogonal arrays, G inverse, and shape analysis. I am also not expert in some of these. Okay. So that is why he was really a legend. Okay. Making fundamental contributions in diverse things and also developing the institute itself. Okay. So here I will stop. Thank you. Now, if anyone has a questions, you can ask me.
If you have any queries, you please ask Professor Rao. He will be happy to answer you. Hello. Are there any
Yeah.
questions or queries?
Okay.
Or if you require any clarifications also, you please post them.
You see, I will just say one more thing. You see, many of us do research, but our research, television research journals,
Yes, sir.
and somebody else reads and probably does more and so on. But if you look at Dr. Rao's research, it has gone to textbooks. That is a greatest. It is so basic, it has gone to textbooks. Okay.
Sir, I think perhaps let me add one thing to you, what you just
please.
said. I think it is because most of the problems that he worked on, they came from looking at the data.
Right.
And looking those multivariate methods that he had developed has its origin from looking at the data at Jebel Moya
Right.
and ancient anthropometric measurements. And the other thing that you just said, the radiation effect, influence of radiation, that
Right.
also is a data from Japan after that bomb attack.
Ah, correct.
Yeah.
Yes. Yeah.
So that is perhaps the primary reason why students also learn his contributions, as you correctly pointed out.
Correct. Yes. Yeah.
Any other queries, please?
Can I ask some one question?
Yes, please.
Please.
What is the major contribution on human development using his research work?
Oh, major contributions. Right?
Yes, on human development.
On human development, I am not quite sure, but the point is, when you apply the statistical methods, Fisher, for example, you said Fishers and so on, okay? There are lots of things that they have discovered about estimating proportion of alleles and so on by using statistical methods. Okay? And when you say human development, that basically includes several other things, okay? Like financially, how are we progressing? Health-wise, how is the society progressing? Etc. So on the one hand, as a society, that is a human development. Okay? Now, if you want to do that, definitely you will need statistics, right? And whatever statistics you collect, you may interview 10,000 people, or I don't know, collect data. But you have to summarize the data, okay, and come up with a number or two numbers, okay. This is where all the thing about estimators and so on helps, okay. This is what I said is too general, but if you remember this thing from National Sample Survey Organization that Mahalanobis started, which we have now destroyed, that used to collect data. And from that data, government used to know consumer expenditure, unemployment rate, everything. Okay, these are all regarding development. Okay, and that is where again these techniques would be useful. Incidentally, this Kramer Rao inequality, there is a paper which derives Heisenberg uncertainty principle in physics using this Kramer Rao inequality. Okay, both are related. So on the one hand, there is a theoretical work. On the other hand, practical work. If you look at ISI of those days, Sir Rao was doing a lot of theoretical work, and Mahalanobis was trying to concentrate on some theoretical work. He also definitely has Mahalanobis T-square and so on, but mostly practical work, how to be useful. Okay. So both go hand in hand. You can ask me any further question if I am unclear or if you are not satisfied. Please ask, don't leave it.
Yes.
Okay.
I understood. He made a lot of tools to identify the result of the data and all that.
Right.
And yes. One more question. He has received the prestigious, award. What is the, is it a award for the entire contribution he has made to the statistics or a specific?
I don't know exactly. I have not read the citations for the award, but the award he received last year, which newspapers sort of said like Nobel in statistics and so on, I don't know. That may be for the entire lifetime's work. Okay. Yes.
Okay, thank you.
That is for the entire. Yeah.
Thanks a lot for your, explanation and the words on his life and works and all that. Thank you.
Okay. So, thank you all. Yeah, but unfortunately, nowadays, we don't seem to depend too much on statistics. Very sad.
Is there any particular reason for that?
Well, I think there is a reason. And in olden days, when Mahalanobis was there, we were conducting the national sample survey periodically and getting data. As soon as the data comes, it is called raw data. Raw data is already in public domain. If there are errors, people can recognize and suggest how to avoid them and so on. Everything is in public domain. But right now, whatever data is collected, unless it suits some people, we don't put it in the domain. Okay. You see, for example, the unemployment survey, we have junked. Some statisticians resigned from the committee. Okay. But we did not. Even more recently, there is this health survey or something conducted by some Bombay organization.
IIPS, sir. IIPS.
Yes, and unfortunately, just at that time, we remembered somebody should be dismissed. Okay. But what happens to the report? I don't know. Even more recently, even the TB drug, right? There is much news about not having enough supply of TB drugs. Okay. Even the United Nations officials were very worried about the situation here. But our government said, no, there is 5. But where is the statistics? If you say 5, is it enough? No. We seem to depend, okay, on voting, okay, rather than statistics. Most of the things we have sort of dismantled. Okay. I think some years ago, there was a question in the parliament. How many health workers died during the COVID? Health workers. And the straight face answer, we do not have statistics.
Yeah, got it.
In parliament.
You said it.
Yeah.
So that is the kind of situation we are in now, you see.
Absolutely.
But if only we collect all the data, unemployment, a consumer expenditure survey, by the way, sometime back, just last year, conducted, that also we checked. We said, no, it is wrong. But what is the wrong in it? We never say that. You see, that tells how poor people are. You see, if people are spending less, obviously they don't have enough money. Something is going wrong. Okay? Consumer expenditure is very important. But we don't accept the survey. We don't say what is wrong. You see? So the human development and so on and so forth, only if you look at all the data, collect, okay, irrespective of what you felt, whether it suits you or not, okay, there's no use of statistics. So I think that may be the reason now. I don't know.
Yeah, it's a very good. That's
Yeah.
really, it's very
Yeah.
alarming also.
It's very alarming now. Statistics, we are sort of pushed it down. You see?
Yeah.
On this COVID
Thank you for.
on this COVID front, it is learned that government has collected a lot of data, but it is not available for analyzing to the statistical community or any other community. This is also, that means
I see.
data is available, but it's not given to anybody.
I see. Maybe that's available.
This
You
is
see,
also,
United Nations shamed us that your data is wrong about the COVID. But we kept on
Yeah.
insisting data is right.
Yeah, the
Okay.
authenticity is also in question actually. When the data may be there. Yeah, you are right.
Yeah.
Thank you, sir. That's a
Okay, so
really-
thank you all. So
Thank you, sir. Thank you
I
for
shall
the
leave now.
enlightening
Okay.
words,
Okay.
enlightening talk.
Thank you all for the kindness and so on. Yeah. I hope statistics again takes front seat sometime soon.
Yes, sir. Let's hope so.
Me too. Yeah.
Okay, thank you.
Thank you,
Yeah.
sir.
Let's Satheesh conclude. Please carry.
Okay. I think Professor Kundu was here for some time. I saw him in the participants list.
Right.
I hope he is here. Let me also once again extend our gratitude to both the professors for their enlightening talk and discussions that ensued. Okay. Is there anything more required, Ramesh?
No. I'll do. Yeah, we just because if any of the participants want to contribute or share something about Dr. Rao or any of what you learned, listen now, you can share. You may wait for some more time, otherwise we'll close it with a lot of time.
I think perhaps I will add a couple of anecdotes regarding
Yes,
Professor Rao's life. Not exactly contributions, because those aspects already that two eminent professors has covered. For this particular session, I went through some of his own writings, so that I collected some anecdotes. So I think it will be worthwhile to put it here. Actually, he says that he came to study statistics or had a career in statistics simply by chance. Because after his MA in mathematics, he applied for various jobs, but he didn't succeed to land in any one of those jobs. And finally, when the Second World War broke out, he applied for a post of mathematician, computational mathematician in army service. And there also, for the interview, he went to Calcutta. He was not selected. But while staying there in a hotel, he happened to meet one Subramanian, who was there in Calcutta to attend a training session in Indian Statistical Institute. So he inquired about this institute, which was not known till then. And Mr. Subramaniam took him over to Indian Statistical Institute, and then seeing the potential of that science of statistics from Mr. Subramaniam, he straight away enrolled for that training course in statistics. And parallelly, he completed the first master's program in statistics from Calcutta University. And at the end of it, he joined Indian Statistical Institute as a trainee statistician for a salary of ₹75. Professor B V Rao was emphasizing the role of data, and Professor Sir Rao looked at it in a similar fashion. He called it scrutiny of data. To quote Professor Mahalanobis and Professor Fisher, the two mentors of Professor Rao, the first task of a statistician is to look for possible inconsistencies in data, to cross-examine the data, that is, putting questions to data and elicit answers. So by doing so, we can see or we can avoid certain pitfalls in taking our decision using statistics. He has given several examples in his books, Statistics and Truth, Putting Chance to Work. It is a very readable account on statistics. The title is also very catchy because when students learn statistics for the first time, they encounter statistics for the first time in their BSc classes, many people come across this quotation: lie, damn lie, and statistics. So that is always something negative for a student to start learning a science. But here the title is Statistics and Truth, Putting Chance to Work. He also expresses his gratitude to Professor Fisher and Mahalanobis, under whose influence he has come to appreciate statistics as the new technology of the present century. He has written these words way back in 1965 in the first edition of his famous book, Linear Statistical Inference and Its Applications, that has been translated to nearly 10 different languages all over the world. Once Professor Rao lost his luggage in a flight from Delhi to Tehran, and he lodged a complaint in Tehran airport, and the next day he got a call from the Mr. Kramer Rao, we have located your luggage. We will deliver it to your hotel. So he clarified, I am not Kramer Rao, I am CR Rao. Obviously, that person thought CR is an abbreviation for Kramer Rao. Regarding the Rao-Blackwell theorem that our Professor B V Rao just explained, Rao's observation in simple words. The Rao-Blackwell theorem gave us a first-time demonstrable justification for using a sufficient statistics in place of the entire sample. Use of sufficient statistics in place of the entire sample for statistical inference. That was a first-time demonstrable justification for. He always looked for such justifications in most of the results. Unless it is purely mathematical, such justifications always he highlighted in his teachings. So that's all from my side that I had to share regarding my reading of Professor Rao, his books. Those things all have enlightened me, and it has motivated me over the years since my MSc classes.
Thank you.
So that's all.
Thank you. Yeah, thank you, Dr. Satheesh. I think we may close it now. How about Adul? Can you close it right now? If anyone doesn't have any questions or any queries or any comments.
Yes, any questions or comments are welcome.
Yeah.
Because this Science People's Forum, this is a developing thing. So even if your comments are on the negative side, we will try to improve our next session onwards, incorporating your views. That is how we develop.
I think we will close it now.
Okay.
I think both the process are left now. Dr. Kundu and
Professor V Rao.
R Rao, yeah. Both of us left now, otherwise we have been happy while they were here also at this time of lot of time. Anyway, I would say many thanks to Professor Satheesh and for doing all this coordination and moderating the session. And even though despite some disturbances in the connections and connectivity and the network, it was a really good session. And really, we had very important revelations about Dr. Rao and really gave some very interesting facts and about Dr. Rao. And we thank everyone and both of them we thank especially and others Ratik for moderating session and everyone who participated in this event. And we always go with your support all the sessions, and we hope to continue your support in the coming sessions also. And we also request everyone to circulate these sessions going to be uploaded in the YouTube, and so that it will reach and people can know more about Dr. Rao in the coming days. And thank you everyone, and we will come back for another session after 2 weeks. And we thank you everyone. Thank you from Science Space. Thank you.
Thank you all.